Have you ever gazed up at the night sky and wondered not about the past, but about the deepest, most distant future? Our journey today isn't measured in years or centuries, but in eons, as we travel to the very end of time itself. So let's embark on a chronological journey from our familiar world to the final moments of the cosmos. 100,000 years from now, the stars in our night sky will look completely different. The slow, relentless dance of stellar drift will have redrawn the constellations our ancestors knew into unrecognizable new patterns. Humanity, if we are still around, might have spread far beyond Earth, but our home planet itself will face dramatic changes. Geologically, a new supercontinent may begin to form, and the site of our current cities could be deep underwater or ground into dust. In about 1 million years, the massive star Betelgeuse will have long since exploded in a brilliant supernova. For a brief period, it would have been visible even during the day, a spectacular final salute from a dying giant. The remnants of our own civilization will be almost entirely gone by then. Our grandest structures, our concrete cities and steel towers, will have eroded away, leaving behind only the most resilient of our creations, perhaps buried deep beneath layers of rock. Fast forward to 50 million years from today, Mars might have developed a thin, breathable atmosphere, perhaps through terraforming efforts or natural processes. Phobos, its closest moon, will have spiraled too close and been torn apart by gravity, forming a magnificent ring system around the red planet. Back on Earth, the continents will have merged into a new, vast landmass, altering global climates in ways we can barely imagine. The stage is set for entirely new forms of life to evolve and dominate the planet long after our own chapter has closed. Let's jump ahead to 600 million years. The sun's slow but steady increase in luminosity will have a catastrophic effect on Earth. The rising temperatures will accelerate the weathering of silicate rocks, which traps carbon dioxide from the atmosphere. This process will eventually starve plant life of the CO2 it needs for photosynthesis. The great forests and phytoplankton blooms that produce our oxygen will vanish, and the planet's complex ecosystems will collapse. Earth will begin its slow return to a world dominated by single-celled organisms. At the 1 billion-year mark, the sun will be 10% brighter than it is today. This extra energy will trigger a runaway greenhouse effect, causing Earth's oceans to boil away into the atmosphere. Our blue planet will become a scorching, arid wasteland, hotter than Venus is now. Life as we know it will be completely extinguished. The final microbes clinging to existence in the last pockets of liquid water will be gone. And Earth will become a sterile, silent globe, orbiting a star that has turned against its own creation. The sun's life is now entering its final dramatic stages. In about 5 billion years, it will exhaust the hydrogen fuel in its core and begin to swell into a red giant. Its outer layers will expand dramatically, engulfing Mercury and Venus. Earth's fate hangs in the balance. It might be consumed by the expanding sun, or it might be pushed into a wider, safer orbit. Even if it survives, its surface will be a molten sea of rock, its atmosphere stripped away by the intense solar winds. The sun will appear as a colossal fiery orb filling most of the sky. After about 7.5 billion years, the sun will reach its maximum size as a red giant. Its core will be hot enough to fuse helium into carbon and oxygen. For a few 100 million years, it will be a bloated, pulsating star, a shadow of its former, stable self. Eventually, the sun will shed its outer layers, creating a beautiful, ephemeral, planetary nebula. This colorful shroud of gas will expand into space, enriching the interstellar medium with heavier elements forged in the heart of our star. What remains of the sun, about 8 billion years from now, will be a white dwarf. A super-dense, Earth-sized remnant of its core. It will shine with a brilliant white light from its residual heat. It will no longer generate new energy through fusion. The surviving planets, including the charred husk of Earth, will continue their silent orbits around this stellar ghost. The solar system will become a cold, dark, and lonely place, illuminated only by the fading light of its dead star. Our journey now takes us into the truly deep future. 100 billion years from now, the expansion of the universe will have pushed all galaxies beyond our local group over the cosmic horizon. From our vantage point, the universe will appear almost empty. The night sky will be a black void, punctuated only by the remaining stars of the Milky Way and Andromeda, which by then will have merged into a single massive galaxy nicknamed Milkomeda. Let's move to 1 trillion years. Star formation in our merged galaxy will have long since ceased. The raw materials, the great clouds of gas and dust, will have been used up. The universe enters what is known as the degenerate era. The only sources of light will be the long-lived, dim red dwarf stars and the slowly cooling white dwarfs. The universe will become an increasingly dark and cold place, a cosmic graveyard of stellar remnants. After 100 trillion years, the very last of the red dwarf stars will finally exhaust their fuel and fade away, becoming white dwarfs themselves. The universe will be plunged into an almost absolute darkness, broken only by the occasional flicker of colliding stellar remnants. This is the era of black holes. The universe will be populated by these silent gravitational behemoths, along with cold brown dwarfs, neutron stars, and the frozen cinders of white dwarfs. Gravity is the only force still playing a meaningful game on a cosmic scale. Even these incredibly massive objects are not eternal. According to Stephen Hawking's theories, black holes themselves will slowly evaporate over unimaginable timescales through a process known as Hawking radiation. A stellar mass black hole will take around 10 to the power of 67 years to evaporate. The supermassive black holes at the centers of galaxies will take vastly longer, perhaps 10 to the power of 100 years. As the last black hole radiates its mass away in a final weak flash of particles, the universe will enter its final state. This is the heat death of the universe, a concept that emerges from the second law of thermodynamics. All matter will have decayed into a thin, featureless soup of fundamental particles and low-energy radiation, spread out evenly across a vast and ever-expanding cosmos. All organized structures, from galaxies to atoms, will be gone. In this final era, time itself loses its meaning. The universe will be in a state of maximum entropy, a perfect equilibrium. There will be no more change, no more complexity, no more flow of energy. There will be no light, no heat, no life, and no thought. Just a cold, dark, and empty void, stretching into an eternal, unchanging infinity. The cosmic story, which began with a flash of brilliant light and energy, will end in a silent, featureless whisper. Our journey through the far future is a humbling reminder of our fleeting moment in the cosmic calendar. It inspires a profound appreciation for the vibrant, dynamic, and life-filled universe we inhabit right now. Thank you for joining us on this existential voyage. If you find these cosmic explorations as fascinating as we do, be sure to subscribe to Space Repo for more journeys into the unknown.